Well, welcome today to Tim's Take, and we are with Dr. Zach Leeser, our state extension climatologist.
Yes, thank you for having me, Tim.
You know, Zach, the climatologist, you either get credit or get blamed for everything.
Yes, absolutely. And sometimes it feels like it can be both at the same time, depending on what the weather is doing in Missouri, too.
And we had that this past year. We had very wet conditions. Actually, we thought we were going to have a really great growing season. Then it turns out dry.
Yes, and that kind of happened last year, too.
It did, didn't it? And what causes that?
Yeah, so, this year we really flipped the switch. It was wet in April, May, and June. And in fact, some areas in southeast and southern Missouri were too wet. April was the fourth wettest April on record for the state, with records going back to 1895. And a lot of that was from southeast and southern Missouri as well. So that started out the season. But once we got to July, really midway through July, I-70 and south in the state, the rain really shut off. And we didn't see significant precipitation until this last week here in mid-September. So that's been tricky to watch here. And it's really characteristic, though, of Missouri's climate. Being in the center of the U.S., we have a continental climate, which means we get all four seasons, but it also means we can get all of these air masses moving from around us. And so it's really easy to switch from maybe a wet pattern to a dry pattern. In this part of the country, in the central of the U.S., that's really a notable thing. And so the past 2 years, we've seen that switch from wet to dry so quickly that we actually call that a flash drought. Mm-hmm. And so that's different from a regular drought where we think about monthly or seasonal differences and kind of a long-term drought event. These flash droughts, once the rain stops and if it's really hot like in July or August, you see conditions evolve in just a few weeks as opposed to throughout the season. And so that's been 2 consecutive years with the flash drought.
Is that because the jet stream has went back north?
Yeah, so we're really prone this time of year for the jet stream to retreat far to the north, and then that leaves us just looking at scattered precipitation chances. So once that jet stream moves to the north, we don't get these big low-pressure systems with the front moving through where the whole state's going to get needed rainfall. Instead, like we saw this summer, even when we got some rain in July and August, it was these pop-up thunderstorms, and it was tough to really get a good rainfall from those. And so that's been tricky, and is something we're still seeing here as we're warm going into October is no sign of that jet stream currently.
Wow. And a lot of times we're so dry that when we do start getting the big front coming through, it just all evaporates before it gets to a dry area.
Yes, and that's been something that always interests me is researching land-atmosphere interactions. And so learning how a dry ground, dry vegetation can actually impact how much moisture is in the lower atmosphere. And so you're right, as these systems move across, we do know that just those boundary conditions can also influence and maybe weaken some of the amount of moisture there too. So kind of fascinating, but scary also, because when you're in drought, it can kind of lead to more drought.
Right, because it seems like it takes a really big system to end a drought and start going back the other way.
Yes, and that's what we saw last year. It was around Halloween into the first week of November. We just got several rounds of significant rainfall, and it kind of helped us out. And so that'll be the big question at this point, because now we've had this drought over the past couple of months, and we now see these precipitation deficits. The rain was helpful last week in mid-September, but we need to see kind of a wetter pattern, like you mentioned, to fully recover and end this drought.
So do some of our big droughts start actually in the fall, late summer of the previous year in fall?
Yes. So we don't always see a full growing season drought. And even just looking at the past 4 years, we've had a drought every year, but 22, 24, and now 25 were just kind of late season events. And so that's been interesting to me, learning about Missouri's kind of drought characteristics, because it has a lot of impacts on what the ag impacts are as well. Because if we saw this full growing season drought, we might have issues everywhere, but when it's certain times of the year, it really changes that too.
So the wintertime, late fall, winter can change that. can gets back to more of a normal pattern again?
Yeah, so usually during the winter, on average, that's a time of year when we do see some soil moisture recharge, and so that's really important to have that precip as we go into the winter and even during those colder months, so that once we get into the spring next year, we're not starting with reduced soil moisture there.
So, speaking of this fall and winter, what are you thinking?
Yeah, so, as we speak today, looking at the first week of October, unfortunately, it looks like we've seen warm and dry. And so we are still dealing with drought here, and we'll be looking for rainfall. Unfortunately, the kind of official outlook for October from the Climate Prediction Center and NOAA is leaning on the dry side. So they're calling for slightly drier than average, or the probability of slightly drier than average conditions. And so one takeaway I have from their forecast is, though it isn't very strong on the probabilities for dryness, but there's not much of an indication of a wet October in their forecast. And so to me, that says the drought will kind of persist or even get worse if we do have a dry October there. So that's a little concerning. And then also to kind of go along with that dry forecast, they're forecasting a higher probability of above average temperatures too. And so kind of what we'd call a persistence forecast. So we had a warm and dry September and August. So we would expect that into October too. So maybe a late frost as a result of that, because once we get into that third and last week of October, that's when on average we see that first frost, unless you're in St. Louis or the Boot Heel, where it's a little bit later into November, and then the drought there. And then looking into the long term, though, there might be a little bit more optimism. One thing we're looking for is the chance of a La Nina. And so last year was a La Nina winter, and when we look back for the state, it was characterized by a really active start to the winter. November and December, we had a lot of rainfall, and then we got into this cold and snowy pattern as well. And that's really what we typically see in this part of the country for a La Nina event, and so we're watching that now. The kind of factor that's making it a little bit difficult is La Nina is where we monitor the Pacific Ocean sea surface temperatures. And when they're cooler than average, that's these La Nina events. And right now, the temperatures are actually closer to normal. We jokingly call it a La Nada because we haven't gotten to that La Nina yet. But the forecast is for over the next couple of months, the temperatures to cool enough where we're officially in a La Nina. But it's expected to be a really weak La Nina, just barely crossing that threshold, and then maybe not last that long. And so as a seasonal forecaster, that's usually the first thing we look at is El Nino or La Nina. That explains a lot of the variance for a season, but we don't have that tool as much if it's a weak or short-lived La Nina. So I'd be optimistic for a La Nina winter like last year where we did see drought recovery. But as of right now, that maybe cold and snowy or cold and wet forecast could be have a lot of uncertainty behind it too.
So if we don't, so if we have a weak La Nina, what about then the spring and next summer? Do we have any idea on that?
Yeah, so these models that try and forecast the really slow changes of ocean temperatures, they are predicting us to eventually warm into an El Nino next year. But I will note that the models have really struggled this past year. I think they've been slow to the changes. They've been predicting this La Nina event to happen since this summer, but it kind of keeps getting pushed back. And so while next year could be an El Nino of a year, and that's kind of what they're showing, still a lot of uncertainty there.
So if we're in between El Nino and La Nina, what usually happens? What's a typical summer like then?
Yeah, so that's when we don't have as much kind of good, what we call composites or analog years. So when we don't have the El Nino or La Nina, that we see these characteristics, there's not as much of a consensus on what the weather will be. And so you see a lot of variability, and it's difficult to kind of make a forecast when you don't have this signal here. So, and this year, it's hard to tell if maybe as these surface or as these sea surface temperatures started to cool, is that why we got dry? Because usually a La Nina can mean a drier fall, but it's still such a weak La Nina. It's hard to really draw that relationship.
So what were we in last spring and this summer then? Were we just in between, or were we El Nino?
Yeah, so actually we came out of La Nina last year. Warmed into this La Nada. We were wondering if we would go into an El Nino, and then now have kind of dipped back into La Nina, and will be over the next couple of months. So, and that happens too. You don't always flip from El Nino to La Nina. Sometimes, like this year, we can go to normal and then back to La Nina. So that's been kind of an interesting thing to see this year.
You know, in my career, as far as agricultural career for 40, almost 50 years, I guess now, the two biggest droughts, 1980 and 2012, to me, all started that fall. Because both times we had these beautiful falls of getting everything harvested. And then we followed up with a really bad summer. And so that was probably a La Nina, then going to El Nino, wasn't it?
Yes.
That's when that happens.
Yeah, and that would explain especially 2012 too, where we also went from that wet year in 2011, which probably led to a good harvest, but then dried out and got into really one of our more extreme, not just drought, but warmest year on record too. So that was a very strong El Nino event too. And so, and that observation is really why we watch these as climatologists, is because the ocean temperatures evolve so slowly that they really do have an impact on these longer term trends. So an El Nino is not going to help you forecast like a thunderstorm this week or with the 7-day forecast, but these, 3 to 6 month kind of cooling or warming trends, you can really try and follow that way.
And then blocking highs can have a lot to do with it too, can't it?
Yeah, so a lot of times when we get in a heat wave or just kind of a drought like this fall, you hear about these blocking highs or a heat dome, just an area of high pressure that's really suppressing any kind of convection or moisture. Those can be related to El Nino and La Nina when you get a blocking high for a few weeks or a few months. And that's because it's not just those ocean temperatures that are directly impacting our temperatures and precip, but they're impacting the just general atmospheric circulation, so the global jet stream as well. And so you see these El Nino, La Nina impacts everywhere here as well.
So what in the world changes the temperature of the ocean off the coast of South America? What changes that?
Yeah, so it's really kind of an interesting phenomenon, and it's a cycle and a feedback between the atmosphere and ocean as well. And so eventually what you get is a low pressure that sets up kind of stationary off the coast of South America. And so that low pressure is generally kind of rising air there at the surface, and that starts bringing up cooler water from below the surface there as well. And then your low pressure also sets up with a kind of a high pressure farther west, and you get this westerly flow, where now you move that cool water to the area of higher pressure too there as well. And so this kind of goes back and forth, this process where you'll develop the atmospheric pressure that pulls the water and then moves it across. And so basically you've got this dipole in the eastern and western Pacific of cooler and warmer sea surface temperatures. And so when we measure El Nino or La Nina, there's actually several different boxes, but the most commonly used is called the 3.4, and it's kind of just generally across the whole Pacific, but from 5 degrees south to 5 degrees north. So that's where you'll really see those changes in the water temperature.
And because they're southwest of us, that's where it affects us, isn't it? I suppose.
Yeah. So, but we really see the global effects, because there at the equator, this kind of starts where we see our global circulation patterns, where ultimately the jet stream and all these highs and low pressure, they're really designed to move heat from the equator to the poles. And so when you change what's going on at the equator, it really changed kind of the patterns as well. And so that's why it's so important in that area in the Pacific.
They have documented some ice that we're losing in Antarctica. Can that affect everything? These patterns too?
Yeah, so that's where it gets tricky. So we've seen quite a bit of sea ice loss in both poles, including the Antarctic, and that can impact global sea surface temperatures as well if there's enough kind of ice there. So as a climatologist, we're kind of constantly trying to look at these sea surface temperatures relative to normal. And so, there's a lot of uncertainty with the ice because it doesn't just go into the ocean and immediately cool the water. It can also impact sea surface currents, which impact how different temperature of water kind of piles up in the oceans there. So we're measuring the sea surface temperature in this box, but if it is changing due to other factors, we might be a little bit off on what our La Nina or El Nino is.
Sure, because the ice reflects sun, doesn't it?
Yes, yeah.
So that can change the amount of heat absorbed and all that kind of
Yes, and so you could have cooling from the ice, but also then you're removing your protection there as well. So then now the water's absorbing more of that sunlight too. So a lot of things that can change.
It looks like for 2025, 2026 winter, we're setting up somewhat like last year, but maybe not quite as strong.
Correct. Yes, and so. For me, I'm looking for kind of an active pattern in the winter, and could be snowy, especially once we get into January and February when we see most of our snow, and maybe cooler temperatures there as well.
But a beautiful harvest.
A beautiful harvest, yeah. So, I mean, some are enjoying this dry pattern in early October if you do need to get out there.
Last couple of falls, I've planted wheat, and I always keep remembering if you plant wheat in the dust, your bins robust, and we've had some really good wheat yields in the spring. So
yes, and I think hopefully this year the mid-September rain will help for some fall planting too. If we hadn't got that, things might be a little bit more dire with the drought situation.
All right, well, thanks. So we do have something to look forward to that could break this pattern, and by next spring and summer we could be in totally different, back into a more of a normal rainfall pattern.
Yes, there is reason for optimism. And I'll note too, we've gone now 4 consecutive growing seasons with drought, and I've gotten the question, how rare is that in Missouri? And these have been severe droughts as well, going up to D2 or D3 on the U.S. Drought Monitor. And so looking back at our climate, we do see these long stretches, but it is getting pretty rare. So some of our longest droughts ever would be from 1931 to 36. We had 5 consecutive growing seasons in the Dust Bowl. Maybe some relief in the winter, but if you look at just April to November, they just kept getting hit with drought. And then also the early 50s, so 1950 through 54, 5 consecutive drought years there. So we're not as extreme each of the past few years as some of those in the 30s and 50s, but if we saw another drought year, that's one of the longest stretches on our climate record. So it has been kind of an unusual drought stretch there.
Yeah, I've always heard my dad and those groups talking about the 30s and the 50s being pretty rough years.
Yeah, the 50s don't get as much attention because I think that we learned so much from the Dust Bowl that the impacts were a little bit better mitigated, but still, just from a weather perspective, it was just as hot and dry then as far as extremes.
I heard some farmers talking about how much more drought-tolerant corn is now than it used to be.
Yes.
And that's mitigated some of these issues.
And I've seen that too. I don't have a lot of expertise with the yields, but when I look at the climate data and then corn yields, for example, in Missouri over the past 30 years, you see this increasing yield, and it's sometimes hard as a climatologist to look at that year and see maybe a drought or no drought and the impact it has on the corn because they've definitely become more resilient, and you still get high yields when the weather's not perfect.
I was looking at the Sanborn field data, and I was trying to figure out when we went with hybrid corn, did that make a difference on the resiliency, to the drought and such.
Yeah.
But I also saw in that period you're talking about in the early 30s some zero corn yields.
Wow. And I think today you wouldn't see those
No.
zeros.
No,
you
you
could at
wouldn't.
least grow something and
Right.
manage. So that's
Right.
fascinating.
Even compared, we mentioned 1980 earlier in 2012. Yeah, it was 12 was just as bad as 80.
Sure.
But we had a lot more corn yield
Yes.
and soybean yield. So our breeders are helping us out a lot on that.
Yeah, and it's exciting for me too because all I do as a climatologist is tell us how dry it is, but it's good that there's hope. You know, others are finding ways to address this situation where we're going to see drought in Missouri. What practices or what breeding techniques can make things more resilient?
Yeah, I know we take a lot of soil data in the summer without cover crops, and we're seeing that we have more soil moisture in the middle of the summer with a cover crop than we do without.
Yes.
Little things like that we can do.
Yeah, and I definitely, coming from a non-ag background, but talking to farmers about drought, hear a lot about that. They're thinking about solutions like cover crops or what different forages can they plant that might be a little bit more resilient to drought. And so that's really interesting to learn about as well.
All right. Well, before we close on this, anything else you want to say about our forecast over the next 6 months or so?
Yeah, well, whenever kind of forecasting drought, I hope I'm wrong and we see a lot of rainfall here and a quicker recovery than expected.
Well, let's wait till harvest gets done first.
Yes, that's a good compromise.
That's right. All right.